Alrighty then, it has been a while since the last time I've done a devlog, and a lot has changed with regards to the performance of this engine. So, as anyone who has seen any of my previous devlogs or videos can tell, my performance has shot up a lot, and I will get into that in a second. But as you can probably have read by the title, I've implemented fog into the game, other types of shading, and I've also implemented mainly pixel shading. I've also implemented some other features in the game that were mostly going to be in how I draw things. So as you can tell, the first thing that I've done here is that you can tell that my drawing routines have become a lot better. I actually figured out what was wrong with my texture mapping. So essentially what had happened was in my clipping routines, in my output triangles, I forgot to call it for each time there's a new triangle. Here, when I first initialized like an array of triangles, it kept outputting to this set, and the data had got lost throughout the pipeline of the clipping, and I forgot to reset it each time. And then so that was why the pixels became distorted, and that was very unfortunate. It took me a while to get connected with someone who could actually help me figure that out. So yeah, now my performance is much better. I can actually move around this map and not have insane lag, right? I can move around fairly normally, and this is at 60 frames per second. I can go at around 140 and make it even smoother than this, but this is fairly decent. So that was the actually last thing that I've implemented. Another thing that helped with this performance is after the texture mapping was my drawing routines. Um I ended up implementing what is called a frame buffer into the game. So I just have an array of pixels that I set up that I draw into with my textures. So each pixel on the screen has an RBG value that's connected to it. So in my drawing routines here, I implemented a draw function that took in an array of integers that was serviced RBG values, the pixels, an X and Y coordinate as to where this pixel should be located, and a color. So, using this is a very common routine. So, X plus Y times the width of your screen, and then I got the RBG value from the color that you input. So the problem that happened before with regards to the performance was that essentially I was instantiating a color object, and the get RBG method takes a lot of rendering CPU processing power, and my drawing routine, my draw function, before I would call the graphics class, and I would call draw line. And then so this draw line function eats up at the performance. So I'm going to show you like how badly and how costly it is to do this. So I'm going to j plus 1, I plus 1, and copy this and do it up here just to show you how bad it gets. So if we use this draw line function, oh, I see what happened. Okay, wait. If I'm not going to use my pixels, I need to stop drawing to it. Okay, so this is my performance. Insanely bad, right? Like, this is a huge dip in performance, and it's all due to that draw line being an incredibly expensive function to call per frame. And then so using the frame buffer, I don't have to use this costly graphics function. I can just draw to my frame buffer. I can just feed it information. I need to actually go back and draw to it. I can feed it the coordinates, and it just handles it a lot better. So yeah, that was a huge performance boost. And so the way that I did that was that obviously I had a buffered image um here, which I would just I had already had this before. So this buffered image, I just have a method that initializes it and calls it, and then it reads this file. that string path value. And so I have what is called a color model and a memory image source. Now the memory image source essentially creates data necessary to feed pixel information to a buffered image. It just streams that data to the buffered image. And this color model just helps me with the RBG values and says what is the best way to handle specific color values. So here I created a graphics configuration object, and then I gave it some color model information, and then in this initialize function, so here I naturally called the get compatible color model method that is inherited from the jpanel class. I have my width and height of my application. This is my screen size. So here I initialize the size of an integer array called pixels. Then, using the data that I've described, I feed that information to the image producer that will then be able to feed that image to my image buffer. And then so here I populate this image buffer, this pixel array with values. Now I could do, like, for example, color.gray.get RGB, and so it'll fill the background color as being gray. So that's essentially what it does. So I really don't need this background color anymore, but I'll keep it just in case something isn't textured or I don't want texturing in a certain part of the map. Um, so for now, I just have it set to 0, which is just naturally black. Um, so then down here, I believe it's called, right? So then it feeds it the new pixel information, and then I draw that buffer image to the screen that now has that information being streamed to it. So after that, the next thing I've implemented was pixel lighting and implementing fog, which is just a type of pixel lighting. If the only difference is that instead of it being black, it'll be gray, but it's Halloween, so I like this spooky feel. So I looked at some OpenGL libraries that had some functions, and I essentially found that the best way is to check the difference in distance between a particular triangle and the camera. And so depending on that difference, you basically want to blend the color of that specific pixel at that location with the background color. And then so I found a really nice OpenGL library that did it. I looked at some of the functions and how I could possibly create my own utility for that in Java. And then so here we have two methods to play. I mean, two data members to play around with that I call density and gradient. Here I just checked the distance between each triangle and the camera, and then so I did the length of that, and that will give me the distance. And then so this was the function. So here is how to get that how to use that density and that gradient to get the visibility. And so in the texture triangle class, essentially I found a method to blend two colors together, to mix them together, and it takes some very nifty bit shifting and to actually handle it all, and using certain byte information in order to get the RBG values. And then so here I essentially have this background color, and I have the specific color of the buffered image, right? And then I just call that blend method. So I put in the background color, I put in the color of that specific pixel, and then I give it the visibility and how much should it blend in to the background. How much should the background's color project onto the color value? So if I change this to gray, let's see, where is it? The one is gray. Let's go here and let's change the background color to gray. RGB. Let's get the RGB of that. There we go. That's fog. The Silent Hill clone is going to have fog very soon. This is basically a completely fog. As I get further from the camera, it blends in completely with the color. And then as I get closer, it blends less and less with the background. So yeah, it's completely functioning. That's, 100% correct. That's what I wanted. Um, so let's go back to drawing YouTube. So let me just put that back to where I would like it to be. So yeah, besides that, that was basically what I've been up to. Is learning about frame buffering, getting this function to implement fog and doing some drawing optimizations. It's been a pretty lengthy experience to implement all this. I went through a lot of trials and tribulations, but it is here now. I'm not sure what the next thing. I mean, before I was working on scene handling, as you can see here, I have a bunch of meshes here. All of these objects together form a house. I was building a house, so I was working on scene implementation. So adding multiple meshes to the screen, right? Having for each loop to iterate through the through the meshes. And then so that's probably the next thing I'm gonna work on is scene implementation and getting, a lot of things drawn to the screen, different objects, and start, implementing like some of the textures for the Silent Hill game and trying to start on working on the map. So I guess that's probably the next thing I'll be working on. And probably some other fundamentals I need to get down, but so far, this is looking very promising. I mean, you know, the graphics engine I would say is around 60 to 70% done. I mean, from the graphics perspective, I mean, this is almost as good as it gets, really. There's really not much more from a graphics perspective that I have to really do. Besides because of like the map sizes, I will try and implement a binary space partition in order to handle larger maps. I mean, that's probably the next thing that I'm going to try and do. Not sure how hard that'll be for me. I'm not too familiar with binary trees. Like I've used them in class, but I've never actually used them to do something like rendering before. That'll be a new experience for me. Yeah, that'll be the end of this devlog. That's basically wrapping up everything that I had to say.